Section 3.6, combining functions. Sums, differences, and products of quotients. So in order to find the sum, the difference, or the product quotient of two functions, really we're just going to take both of their equations and either add them, subtract them, multiply them, or divide them. The tricky part is finding the domain. But let's see first how we just do those operations. So first, if we want f plus g, all we really mean is that we're going to add the two functions individually, but together. So in example 1, we have that f of x is 1 over x minus 2, and g of x is the square root of x. So if I want to find f plus g of x, I'm just going to take the first function plus the second function, and in this case, we can't combine them any further than this. I mean, I guess you could get a common denominator, but in this case, it doesn't really do anything. So we might as well leave it the way it is. Subtraction is almost identical. It's just going to have a minus sign in the middle. Multiplication, again, very similar. We're just going to multiply them together. So we have 1 over x minus 2 times the square root of x, which really we can think of as the square root of x over x minus 2. And then lastly, we have division, f divided by g of x. So that's going to give us 1 over x minus 2 divided by the square root of x. Don't forget we multiply by the reciprocal. So really that's going to put that square root in the denominator. Okay. So the only thing we have to be really concerned about here is the domain. And when we're saying up here domain of A and domain of B, what we really mean is the domain of this is what we're considering to be A. The domain of this is what we're considering to be the set B. And we want the intersection or the overlap. So let's take a look at what the domains of the functions are separately. So f of x is equal to 1 over x minus 2. The domain there, we just have to account for the fact that the denominator can't be 0. So that's going to be that x cannot equal 2. Here we have a square root. That means that inside x has to be greater than or equal to 0. So both of those rules need to be followed in order to get the domains for these functions. Now, the domain for addition, subtraction, and multiplication is going to all be the same. It's just the overlap of those two rules. So not only does x have to be greater than or equal to 0, and sometimes I like to use a number line for this. Not only does x have to be greater than or equal to 0, and there's my g of x, but it also has to be not equal to 2. So that would be an open circle here. So I need to make sure I'm following both of those rules. So the overlap is that we're using all of the numbers greater than or equal to 0, but not 2. So we'll go from 0 to 2, but skip over it, and 2 to infinity. There's my domain. The only additional issue here is that in the division for this one, the domain also has to include the fact that the new denominator cannot be 0. Notice g of x became our denominator. So we cannot let this equal 0. So we also have to include the fact that the square root of x cannot equal 0, which means x cannot be 0. So we're going to use the same domain as up here, just not including the number 0.